Let's look at the test you took today about relative, absolute age dating, and index fossils. First question here, which best describes the law of superposition? This is when, if it's undisturbed, lower layers contain older rocks than the ones on top of them. So there you go. Lower layers contain older rocks. Upper layers older than the lower. That's not true. They are newer. All right. Now here's a diagram showing 3 different locations that may be far apart from each other. So which fossils are best examples of index? Index fossils should be in only one layer, and they should be in every site. So here we have the trilobite is here and here. That's more than one layer. Ammonite, more than one layer. Yes. Brachiopod, one layer and in all 3 sites. Brachiopod makes the most sense. Okay. Relative and radiometric are used to determine age of fossils and features. Different methods. What's relationship to radiometric? Radiometric is also absolute age dating. Radiometric dating uses radioactive decay to determine the exact age. That's true. Relative age uses location within the layers to compare a material to its surroundings. That should not be apostrophe S. Such shame. Relative age is radioactive decay. No, it does not. They work in the same way. That's not true. There you go. Except for the misspelling, because it is surroundings. Terrible. Which data is most likely to be obtained by studying ice cores? Ice cores, we know, tells us about climate, tells us about concentrations of oxygen and carbon dioxide. So minerals, nope. Oxygen, yes. Which method would be best for scientists to use to determine the absolute age? Absolute age, index, no. Relative. Radiometric, same as absolute. Law of original horizontal, we didn't say that. Superposition only gives a relative age. What's older, which one's newer. That's all. The diagram shows a cross-section of several rock layers and geological features. Based on the diagram, which is true. U is the oldest. U is actually the youngest because of law of cross-cutting relationships. T is older than S. T is younger than S for the same reason, cross-cutting relationships. Z is the youngest. No. U is the youngest. So D has to be right. X is older than Y. X is below Y. Law of superposition tells us this is factual. At a dip-slip fault, pieces of land along with the fault change position vertically when compared to one another. Dip-slip, one side's up, one side's down. This information, the student concludes that the Earth's crust was uplifted years ago due to tectonic movements. If fossils provide evidence for Earth's history, and they do, which evidence would help the student justify this conclusion? Fossils of marine animals found in ocean beds, that's normal. Fossils of land animals found in deep oceanic trenches, that's also possible. Fossils of marine animals found in mountains, that would be weird, but also might show that one goes up and one goes down. Okay, I think that makes the most sense. Through relative dating, the age of a rock was determined to be between 15,000 and 25,000. How long should the half-life be of the radioactive element used to date the rock layer? If it's 1 million or 5 million years old, this is going to be some terrible decimal amount of a half-life, which we don't like decimals or fractions, hard to deal with. But if it's 5, that means it's going to be 3 half-lives up to 5 half-lives, which is a much easier way of determining that. Why are index fossils used as guides to determine the age of rocks? Each lived during a specific period. That's true. Index fossils are very rare. False. All index fossils live during all the periods. No. This defines the better answer. Same in the diagram, the two geologic cross sections for different parts of the world. P and J are the same age because they're on top. That doesn't make any sense. No, two different layers. Layers L and T are the same because they're the same rock. L, T. Not the same rock. There's a Hickam-Doo there, and there's some weird squiggly thing over here. L and P, yeah, no. K and Q the same age because they're both in the top layer. Not true. Obviously, some kind of dip slip or something happened here. M and R are the same because they came to same index fossil. That makes sense. Same index fossil. Yes, great. Last but not least, which isotope has been most often used to determine the age of fossils from living organisms from the past 50,000 years? That is carbon-14. Excellent. That's all.